Okay, we're going to start section 5.1 today. Chapter 5, the focus is on polynomials. And so a couple things that we're going to be looking at today is, first of all, what is a polynomial? And then we're going to look at how to add, subtract, and multiply polynomials together. One of the most important pieces to this particular section are all of these exponent properties that you see here. And so I'm going to save that for the end. It is the most important, but I think the other pieces on this notes page, we can move through it pretty quickly, and then we will double back and focus, spend most of our time on those exponent properties. So I want to just start by looking at what a polynomial is. Okay, and I think one of the easiest ways to discuss what a polynomial is to actually talk about what a polynomial isn't. Okay, so what you see in this box are kind of four things that are sort of disqualifiers. It says here, to be a polynomial, the function cannot, and then there's a list of certain things that cannot be in your function in order to be a polynomial. Okay, by the way, the prefix poly just means many. So we talk about binomials, which are two terms. Trinomials have three terms. Polynomials really encompass anything. A binomial is a polynomial, a trinomial is also a polynomial, or it can have more than three terms to it. Okay, so let's just look at a few of these disqualifiers here. One example is if you have in your function any radicals. So we're talking about if you see a square root or you see a cubic root, that definitely would disqualify that from being a polynomial. And so I'm just going to, as we talk about these disqualifiers, I'm going to glance down here at example 3. It says, determine whether each expression is a polynomial. If it is a polynomial, state the degree of the polynomial. Okay, we'll talk about the degree in just a moment. So we talked about if there is a radical of any sort, square roots, cubic roots, then we're definitely saying that that is not a polynomial. So as you look at these five examples below here, you can see that example B would definitely not be a polynomial. So I'm just going to write down not a, I'll abbreviate here, polynomial. I'm going to give the reason here because there is a radical. Okay, and I'm just going to go ahead and kind of highlight that was the piece that disqualified it. Okay, let's look at something else here. It says it cannot have, we're talking about things that cannot exist here. It cannot have variables in the exponent. So we're talking about, if you have a 2 and then maybe in the exponent is where your variable is. All right, so I'm going to take a look at these examples under here. I don't see that happening in any of these three. And so that particular situation isn't happening in any of these other four. So let's move on to the third disqualifier, and that is you cannot have a fraction as an exponent. So that would be maybe having an x, and then in the exponent you would have some sort of fraction like 1/2, 3/4, something like that. Okay, I'm going to glance down at the examples here and see if I notice that any of the exponents are fractions. I don't see that here, so that's not a reason for why any of these remaining four would not be polynomials. Let's look at our last disqualifier here. It says that cannot have variables in the denominator of the fraction. Now here's something that we want to make sure. Obviously, if you see something like 2 divided by x, but what that also means is you cannot have any negative exponents on your variables if they are in the numerator. And we're going to be discussing up above that property on negative exponents. But if you would see a negative exponent on a numerator, okay, so no negative exponents on a numerator or a denominator that has a variable in it, then that is disqualifying it. Okay, so it's looking like as I look at those, I notice, and I'm going to go ahead and highlight this, here's a couple negative exponents in the numerator, so I'm simply going to write down not a polynomial because negative exponent. Okay, also in example D, I see that there is a variable that is in the denominator, so that would disqualify this. I'm going to say that is not a polynomial because variable in the denominator. Okay, now these other two, A and E, those seem like they're not breaking any of these four kind of disqualifiers here from being a polynomial. So I'm going to go ahead and call both of these polynomials. And then there was a second part to the directions here. It said, if it is a polynomial, to state the degree of the polynomial. Now, what is the degree of a polynomial? The degree of a polynomial is when you look at each term separately, okay? And you take all the variables in that term and you sum the exponents, okay? Whichever term has the highest sum of the exponents on the variables, that number, that sum, is the degree. Okay, so let me give you an example here. Okay, you can see that in example A, this is all one term. Okay, all that's being multiplied together. As soon as we hit the subtraction sign, now we have a second term. Okay, now I'm only interested in the variables and their exponents. So this first term, if I were to add the exponents on those variables, I would get a 7. The only variable in the second term is a 5. So which of these two terms has the highest sum? Well, the 7. So I would call that a 7th degree polynomial. Okay, using that same idea down here in example E, here I have a trinomial. I have 3 terms. So I want to make sure that, any exponents on my variables, if you don't see an exponent, we assume it's a 1. Okay, so I'm going to go ahead and sum this. That would be a 4. I'm going to sum this one. That term, the sum would be a 6. And this one, the sum on the variable exponents only is a 2. So the highest sum was a 6. So I would call that 6th degree. Okay, 6th degree. All right, so now that we've talked about sort of what it takes to be a polynomial or to not be a polynomial, let's go ahead and look at kind of adding, subtracting, and multiplying polynomials. We're going to flip to the back page here of the notes. I have filled out several of these here for you because we're just going to take a look at 2 examples and maybe talk through example B. Okay, here we have a trinomial and we're asked to subtract another trinomial from that. Okay, what you're going to do to get rid of the parentheses is you would identify the number that is in front of the parentheses. The first trinomial simply has a 1 in front of it, but we do have to be careful. This second trinomial has a -1 in front of it because it was subtraction. Okay, you basically distribute the +1, which does nothing, to the first trinomial, and then you distribute a -1 to the second trinomial, which would flip the sign, and then we would simply go through and identify, okay, which terms are like terms that we could combine together. Okay, so 4x squared minus 2x squared would be 2x squared. Okay, here, -5x minus 3x, that would be -8x. And then 6 plus 1, that would give us +7. Okay, it is really that easy. And so I did example B for you. You really just have to make sure, I don't know why this is offset here. This kind of got shifted over. But this should be distributing this -1. That would have flipped the signs here on each of these things. And then again, you're just combining like terms. Okay, so subtracting those 2 polynomials. What you can see here in these 3 problems is this is just multiplication, which is really just the distributive property. Distributing a 3x, please note that when you distribute the 3x into a 2x squared, notice that I added those exponents. And then the 3x to the -4x, I added those exponents. Okay, I just want to look at example B with you, because here we are distributing a 4/3 x cubed. Again, you're going to add the exponents on the x's. Please keep in mind that if these other numbers here don't look like fractions, you could always make them look like fractions by putting them over 1. The 4 and the x squared are going to go to the numerator. Okay, the 3, that's actually going to the denominator. Okay, so initially we get maybe a 24x to the 4th in the numerator, a 3 in the denominator, then a 36x, 3 in the denominator, and then we get -48 again with a 3 in the denominator. Okay, and then we should simplify here. So if we were to simplify this, this would simplify to 8x to the 4th plus 12x cubed minus 16. Oh, I'm sorry, there should be an x squared here, 16x squared. Okay, we are not going to look at this example here, but I do want to look at what if we're not just distributing, and again, this is kind of off kilter a little bit here, but I do want to look at what if we are not just distributing a monomial in, but maybe we're multiplying either two binomials, or in this case, a trinomial and a binomial? What you're going to do is just take the first term in the first set of parentheses, that n squared, and you're going to distribute that n squared to everything in the second set of parentheses. Again, we are adding the exponents. Okay, then you're going to double back and you're going to distribute the 4n to everything in the second set of parentheses, and then finally you will distribute the -6 to everything. Okay, when you get down to there, then you're just simply going to go through and you're going to combine your like terms here. I think that I accidentally, you probably saw that I accidentally left out a squared symbol there. Okay, so these are like terms. I keep it in n squared, but it's 6n squared. Okay, 8n minus 6n, that would be 2n, and then my minus 12, that would be my answer. Okay, I want to focus now on these exponent rules, because this tends to be a little confusing for students, how you simplify exponents, when you're supposed to add exponents, when you're supposed to multiply them. And so what I've included here is a list of the names of the properties, kind of a broad generic definition for that property, but I find that it's more helpful if students have a specific example with numbers in it to see how that property is applied. So I'm going to give you an example to write in here. Once we've kind of written those examples and talked through it, then we'll come on down here and we'll try to walk through some of these here together. Okay, so the product of powers property, by the way, you don't have to memorize these names, you don't need to memorize these definitions. What you need to be able to do is you just need to be able to recognize how to use the property to simplify exponents in a problem. So let's say that you had x squared times x to the 9th. What you're actually doing with those exponents is that's a scenario where you would add those exponents together and say x to the 11th, okay? I want to jump down to this fourth property because it's really this power of a power property and then the product of powers that sometimes students confuse these two. So with a power of a power property, that is often when you might have a variable that has an exponent on it, but then it's in parentheses and that also is then raised to another power. Okay, this is the situation when you multiply those exponents together. Okay, so here we're saying this is when we add the exponents, and over here, this is when we're going to multiply the exponents. Okay, now honestly, the two properties underneath this power of a power property, these are really just extensions of the power of a power property. So I'm going to go ahead and look at these two because it's this same idea. So a power of a product. So that's really just saying what you might have in the parentheses are things that are multiplied together, like a 3 times an x squared times a y, but then that's all raised to the 5th power. Okay, now here's where you have to be a little bit careful. You are allowed to distribute that 5, that exponent, and multiply it times all of the exponents on the inside. And you'll notice I drew in these ones because a y has an exponent, it's just not visible. And even the number 3 has an exponent on it, it's to the 1st power. This 5 can be distributed to each of those, giving you 3 to the 5th, x to the 10th, y to the 5th, and then we would multiply out 3 to the 5th and say that that would be like 243, x to the 10th, y to the 5th. Okay, where you have to be careful is, and I'm just going to put this up above on the notes, if you ever have something in parentheses, but you're not multiplying it all together, you have maybe an addition or a subtraction sign in between here, this is when you absolutely cannot take that exponent and try to distribute it to the exponents on the inside. That situation that I just wrote up here, if it was x plus 2 squared, the only way for you to simplify that is to actually physically write the x plus 2 down twice on your paper, and you must FOIL those together. You distribute the x and then double back and distribute the 2. So this idea right here of where we're distributing this 5, this exponent, you're only allowed to do that if everything inside the parentheses is all being multiplied together. Okay, let's look at another extension of this. This is called the power of a quotient property. So again, this would be if there's no addition or subtraction in the parentheses, but you're simply dividing two terms like x cubed divided by y. I always like to draw in any exponents of 1 just to make sure it's clear that I don't forget to distribute there. And then again, we're multiplying, so this would be x to the 6th divided by y squared. Okay, I'll circle what these final answers are here. Okay, so these three are all really kind of similar. It's the same idea. All right, let's go back and let's take a look at the quotient of powers. Okay, quotient of powers. An example of this might be x squared divided by x to the 5th. Okay, so the way that you can look at this, and I don't expect you to write this like this, but I want you to think in your head that when you see an x squared, what that really means is in the numerator there are 2 x's, and when you see an x to the 5th, it means in the denominator you've got x multiplied times itself 5 times in a row. And so if you picture canceling out pairs of x's from the numerator and denominator, you'll notice you're going to have 3 extra x's left in the denominator, and you won't have any left in the numerator, so you're just going to put a 1 as a placeholder in the numerator, leaving you with x cubed in the denominator. Okay? All right, and then negative exponents. So the way negative exponents work is it allows you to take just that factor, only that variable or just that number that has the negative exponent on it, and you can slide just that term to the opposite location. So for example, if you have x to the negative 7th, you're allowed to move that down to the denominator. That would make the exponent change from a negative 7 to a positive 7. I'm just going to do a second example up here. Let's say that you had an x to the negative 2nd with a 2 in front of it, and then in the denominator you had a y squared and a z to the negative 4th. Okay, you can move, you're supposed to only move just the factor that has the negative exponent. Remember, the 2 is totally separate. That has a totally different exponent. It has a 1, which is not negative. So only the x to the negative 7th should move to the denominator, and only the z to the negative 4th should move to the numerator. The other things, like the 2 and the y squared, those stay exactly where they were at. So the z would come up top and join the 2, and the x would come down at the bottom. It really doesn't matter the order you have these x's or y's here in the bottom. Okay, so the last property, which is squeezed down here at the bottom, this is called the zero power property. Anytime a variable or a number has 0 as its exponent, it will always simplify into the number 1. Okay, it'll always simplify into the number 1. Okay, so let's go ahead and try and see if we can put some of this into action here. I've given us a few steps that I want you to write on your notes page. These are steps for how that we're going to follow for simplifying exponents. We first want to make sure that if there are parentheses in the problem, that we always get rid of those parentheses. So let's look at example A here for starters. Okay, example A. We notice that there are parentheses. I'm going to draw in the exponent that's on the outside of those parentheses, and you'll notice those exponents are just 1s. Okay, so that's not really serving a purpose for me to distribute the exponent of a 1 into those. So in this scenario, those parentheses are not actually serving much of a purpose, so I'm just going to drop them out of the problem. Okay, now I'm going to go ahead and any big numbers like this 2 and this 3, those numbers are going to get multiplied together, okay, into a 6. But then the exponents on these A's, this is the situation like this first property of where I should be adding those exponents together. So I'm going to get a to the first, and then it's just b squared c to the negative 2nd. Now look at the directions here. It says we want to always make sure that we're writing our answer with positive exponents. So you'll see my second step here is we want to make all the negative exponents positive. Well, I only see one one term that has a negative exponent, and it's that c to the negative second. So the thing that will help you, I think, with making negative exponents positive is if you make sure to always make your problem look like a big fraction. So I'm going to put this all over 1, and then the only thing that I'm going to move to the denominator is just that c to the negative second. And once I move it to the bottom, it's now going to be c to the positive second. And then if there was anything else that could be combined or reduced, I should do that, and there's not. So this is my answer. Okay, let's go ahead and look at example B here. I want to look at just a few more of these with you. There are no parentheses for us to get rid of in example B, so I'm not going to need to do anything there. I don't have any negative exponents that I need to make positive, but there is some reducing that I could do. I shouldn't be having 2 q's in the top and 7 q's in the bottom, or 4 r's in the top and 3 r's in the bottom. If you remember this quotient of powers when we had x squared over x to the 5th, and I thought, you know, think about writing out. Don't actually write it out, but in your head, picture that many. What you're going to do is you're kind of subtracting. Wherever there are more q's, when you subtract like these 2 from that 7, okay, that's going to leave you with 5 extra q's in the denominator. Same thing with the r's. There's more r's in the top. There's 1 extra r in the top, so that leaves me with 1 extra r left there. Okay, let's look at example C. Okay, now example C, we do have parentheses. Okay, I notice that inside the parentheses, though, I'm not adding or subtracting things. So I'm going to go ahead and make sure I can see all my exponents. I'm going to draw in that 1 on the negative 2. This is the property of, it's really this one here, the power of a product, where we're multiplying and we're distributing that exponent. So I'm going to take negative 2 and cube it. Then I'm going to multiply the exponents on the A, exponent on the B, and I don't have any negative exponents. Please don't confuse this 2 here. The 2 is negative. The exponent on the 2, that's not negative, okay? So you're not moving that negative 2 to the bottom. You're only shifting things around like we did with this c to the negative second if the exponent is negative. Okay, the one thing that you should do is you should never leave a number raised to a power. We always want to figure out what that is. So if you don't know what negative 2 to the 3rd power is, you could type it into your calculator. It is negative 8, and that's how you should write that when you write your final answer. Okay, let's look at D, and then we're just going to look real briefly here at just like 2 problems underneath here. Okay, now this one, there's no parentheses. There are no negative exponents. I don't want you to confuse these numbers here. These numbers are not exponents, the 15 and the negative 3. So I want you to just think, look, if I just gave you the fraction 15 divided by negative 3, you should be able to reduce that fraction. That fraction is going to reduce basically to the number negative 5. That is what you should do with that. You should reduce that to the negative 5. The negative 5 would be in the denominator. Or I'm sorry, the numerator, okay? Then I see that I have C's in the top and C's in the bottom. There are more in the top, so if I canceled those, I would have 3 extras in the top. Same thing with the D's. If I canceled those, it looks like I would have 4 extras in the bottom, okay? All right, let's go ahead and we're gonna jump to example D. Okay, we'll just look at example D, and this is what we'll wrap up here for the day. Okay, so once again, looking at my steps here, there are no parentheses, but oh my, we have a ton of negative exponents. Please, please, please do not try to cancel these M's and N's if some of them have negative exponents and some have positive. You need to make sure you follow these steps in this order. First, make any negative exponent positive. So I'm going to highlight all my things that have negative exponents, and what I find helpful is I do find it helpful to kind of draw the arrows on the things that I'm going to be moving. That way, if I don't have an arrow drawn, like on the m cubed, I know that's going to stay stationary, and the p squared, that's going to stay in the numerator. But this m to the negative second that's down here in the denominator, I'm going to pull that up to the numerator. Whoops, I didn't mean to make the exponent on that negative, okay? Because once that comes up to the top, the exponent is going to be positive. Okay, in the denominator, the n cubed and the p to the 5th stays there, but I'm also going to bring this n to the negative 4th to the bottom, and it'll become n to the positive 4th. Now, once all your exponents are positive, now look at trying to combine or reduce what's left. And so, for example, here I've got these m's, and they're just kind of side by side. This is the scenario where you add the exponents. Okay, so I'm going to add those exponents. I'm also going to do that on these n's here. Okay, I'm going to add those exponents. And if you look closely, there is one last thing we should do. I shouldn't be having p squared in the top and then also p to the 5th in the bottom. I should be able to cancel and reduce there. So I'm going to have 3 extra p's left in the denominator if I cancel out these p's here. Okay, and that would be your final answer there. Okay, if you have questions, please contact me. But the homework assignment is this worksheet 5.1.